Okay guys, so now we're going to take a look at the back of this worksheet, which is very similar to what we were doing on really both sides, or both sections of it, I should say. So at the top here, you have tell whether each table represents a linear relationship and explain. And you're given numbers that correspond to x coordinates and numbers that correspond to y coordinates. So basically you have 1, 2, 3, 4, 5, 6, 7 points that you're going to plot on a graph. And in fact, I gave you a graph for just that. So we have the point 2, 0, and 4, 1. So I'm going to see if I can do 2 at a time. 2, 0, and 4, 1. So if we go here on this graph, 2 over and 0 up will be right there. And then 1, 2, 3, 4, and 1 up will be there. Next 2 points, 6, 2, and 8, 3. 6, 2, and 8, 3. Remember, you always go x across and y up, and x across first. So 6, 2, and 8, 3. 1, 2, 3, 4, 5, 6. 3, and I forgot the other one. Oh, 6, 2, and 8, 3. So I made a mistake there. 6, 2, and 8, 3. 1, 2, 3, 4, 5, 6. 2, 1, 2, 3, 4, 5, 6, 7, 8, 3. And you see just by those 4 dots, it's looking like it's a pretty good line going right there. But let's go ahead and finish it out. We have 10, 4, and 12, 5. So this is 8, 10, 4. That's 10, and that's 12, 5. Definitely is looking like a line now. And 14, 6. So this would actually be just right on the edge, 14 and 6. So you see, definitely looks to be a line. So yes, if this is problem A, I would say that is yes, and I could even put C graph. That's really all I'm looking for. Because if I see your graph, I see that you've plotted the points, and even if you didn't label all of them, even if you just labeled, let's say, 2, 0 and 14, 6, that would be enough for me, because I see that you've got the points in there. All right, so if that one was A, then let's call this one B. So again, our x-axis and our y-axis. And we may need to augment the scale for this one a little bit. Let's see what we have. Yep, we definitely have to go all the way up to 48. So we might have to make each one 5. How many go up and down? These are kind of tiny, but it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 14 up, yeah, 14 times 5. I think that would definitely give us enough room. Yes, so if we called each line going up vertically 5 units, I think we can make this work. And we can go across 1 for 1. So 1, 0, and 2, 3. You can do this one in red. So 1 over and 0 up, and 2 over and 3. Not even going to be in the line. This is going to be a tight squeeze, but we're going to just do the best we can. We have 3 and 8. So again, 1, 2, 3 over. That would be 5. So 8 would be not quite on the next line. Kind of looking like a line thus far. 4 and 15. 4 and 15. So 4 over, this would be right on the line because we're counting by 5s. Five and 24. So 1, 2, 3, 4, 5. 5, 10, 15, 20, 24 would be right underneath there. Now it's starting to look like it might curve a little bit now. 6 and 35. So 6, 5, 10, 15, 20, 25, 30, 35. That's going to be right on the line. And 7 and 48. So 7, 5, 10, 15, 20, 25, 30, 35, 40, 45, 48 there. So I think that we can agree that a linear relationship would be going like that, whereas this is more of a curved, looks kind of like an exponential curve, and we'll get into those a little bit more. So this one I would say, whoops, is this one a linear relationship? I could simply say no. See graph. That would be good enough for me. Now this next one, wow, we've got some negative numbers now. How do we figure this? Well, we do it the same way. We've got our points, we've got to plot our points, so we're going to take a look and see if it's a line or not. So we have x1, y2. So let's move this down a little bit. So this would be our C, y-axis, x-axis right there in the middle, respectively, for both. And I forgot the numbers. 1, 2. 1, 2, and 4, negative 1. 1, 2, 4, negative 1. So 1 over, 2 up. Now let's do yet a different color. So 1 over, 2 up, and last I forgot the other number again. 4 over and negative 1 down. So we have 1, 2, 3, 4 over and negative 1 down because we have to go below the axis. Okay, 2 dots. Every 2 dots make a straight line, so we don't know for sure yet. 6 and negative 3. So we need to go 4, 5, 6 over, 1, 2, 3. Okay, 3 dots kind of in line. Looks like we're on the right track. 7 and negative 4. So 7, negative 4. So far, so good. 10 and negative 7. So that's 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. Yes, it does still look like that would be a straight line. What else can we squeeze on here? 12 and negative 9. Well, if this is 10, this will be 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. And yes, this definitely looks like it is a, so we go this way, pretty good straight line there. So again, if we were to label 1, 2, and what was our last point that we were able to fit on here? 12 and negative 9. And you say, wait a minute, Mr. Sands, we weren't even able to put the last point on there. That was 16, negative 13. Yes, I see that, but given the graph paper that I gave you, you could extend it out here. You could extend it out here and put the point, and it would still probably connect to that green line if you extended it. But for this case, we've drawn enough points, and it clearly looks to me that you've taken the time to draw them and put them on the right place where they need to be, connected the line, and I see that that definitely makes a straight line. You see that this one made a straight line, so A had a straight line here in the black, and C has a straight line here in green, but red, B, no, that is a curve. They're curving up. And you see that if we went by those first 2 points, they're pretty close together, but if we continue that, if we took a ruler and we connected those lines, that line would be going there like it is in black. the red, it is just making that curve up. So again, what would I need? Just simply, yes, C graph. Can I move this up? Nope. Have to move it up with the mouse. Okay, so for parts A through D, use the equation to complete the table. Tell whether the relationship is linear. Explain. Well, we would do the same. We are given equations. We have to plug in the x variable for x and figure out what we're going to get for y. So we're going to use this equation. We have y equals negative 3x minus 8. So the first one that we're going to put in is x is negative 5. So y equals negative 3 times negative 5 minus 8. Y equals negative number times a negative number, that's a positive number, minus 8. So y equals 15 minus 8 is 7. So this is 7. Okay, so we are 1 for 1. Y equals negative 3x minus 8. Yes, I write the formula every time. Negative 3 times negative 2 minus 8. Y equals negative times a negative. That's going to be positive again. 3 times 2 is 6 minus 8. 6 minus 8, that's going to be a negative 2. We have y equals 3x minus 8. Y equals, this time, x is 1. So this time y equals negative 5. And do I have enough to squeeze right here? Y equals 3x minus 8. Write the equation every time. 3 times 4 minus 8. 12 minus 8. That's going to be 4. Okay, so what does this mean? Now I have 4 new points, and I'm going to plot them again. So this is A. The points that I'm plotting: negative 5, 7, negative 2, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Negative 5, 7. Negative 2, 2. Okay, so far, any 2 points make a straight line. 1 and negative 5. So we go 1 over, 1, 2, 3, 4, 5, down. And 4 and 4. 1, 2, 3, 4, 1, 2, 3, 4. Well, we had a pretty straight line going until that last one. This makes a nice little straight line, but that is not a straight line. So, no. This one is not. Because of this one right here. Okay, we have another equation. Essentially, these are the same. We're given an equation, we have an x, we plug in our numbers for x, we get y, we would graph them on the graph paper that I gave you. That's why I gave it to you, so it would make it a lot easier just to plot them and visually check. The same thing here. You're given numbers for x, you put them in. You're given numbers for x, you put them in. Let's go ahead and do one more, because you notice here that these are the same numbers each time. Negative 3, 0, 3, and 6. A, the first one, just had different numbers for whatever reason. Okay, so let's do this one. We can draw a little line here on our worksheet to separate, so that I know that this is going to be the next thing that we're doing. So y equals 4, x minus 7 plus 6. Always start with the equation. Always start with the equation. First one I'm going to do is x equals negative 3. Okay, this is 4, negative 3 minus 7, negative number minus another negative number means we're moving more down the negative number line in the negative direction, so this is a negative 10 plus 6. 4 times negative 10 would be negative 40 plus 6, so y equals negative 34. Let's put this one in blue. Okay, next one. Again, we always start with the equation, so we can plug and play and not make any mistakes. If I'm writing the equation every time to solve it, that should give you a hint that I'm looking for you to write the equation each time you solve it. Y equals 4, x minus, this time is 0. Oh. Made a little mistake there. Let's just correct that. Y 4, x is 0, minus 7. That's what we're looking for. So this is going to be 4 times negative 7 plus 6. So 4 times negative 7, a positive times a negative is going to be a negative. 4 times 7 is 28, so this is negative 28 plus 6. So y equals negative 22. This was our first answer. This is our second answer. Okay, I think I have just enough room over here to do the third one. Again, always start with the equation. This time x is 3. So make that our 4. That's an ugly 4. Let me erase that so we're clear. So y, 4, 3 minus 7, that's going to be a negative 4 inside the parentheses plus 6. Negative 16 plus 6. Negative 10. And I'm going to do, this is going to be the last one I'm going to show you how to do. And I'm just going to continue going down here, bleeding into the rest of the problem. So that's really leaving you with these two that I'm not going to do for you. But I've worked through the top part and the first two in great detail. So I think that you can clearly see what steps you need to take to finish the rest. So let me finish this one, and then we'll plot this B in blue, and that'll be it. So again, we start with our equation. This time x is 6. Let me move it up a little bit. Six minus 7 is going to be a negative 1. Negative 4 plus 6. Negative 4 plus 6, that's really like 6 minus 4, which is going to be a positive 2. Okay, so now we've got to plot these points. So probably looks like we'll have to go 5s again. Makes it nice and easy. So our first point is negative 3, negative 34. So if we call this one B, so we have negative 3, 1, 2, 3, and then if we count by 5s, negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, excuse me, and of course that's an easy loose count. Negative 5, negative 10, negative 15, negative 20, negative 25, negative 30, negative 35. We said we're going to do blue though. So that is our negative 3, negative 34. We also have 0 and negative 22. 0 is right on the axis. 5, 10, 15, 20, 25, so 22 will be right in there. So that is 0 and negative 22. We have 3 and negative 10. So positive 3, 1, 2, 3, 5, and 10. Now let's see if the fourth one keeps us in line, because it looks like we got 3 dots headed in a straight line thus far. We have a positive 6 and a positive 2. So we need to go 6 over. 1, 2, 3, 4, 5, 6, and 1, 2. Aha! That looks like a straight line. Pretty close. And I might be a little bit off just with the smartboard here. So we said that last one was 6 and 2. This was 0 and negative 10. So that one definitely looks like a straight line. So we could say to this one, yes. So this is a lot of number crunching and a lot of plotting. But this is what we're dealing with this first unit. So for those of you who've had issues, I've worked out the first 2 problems with you very explicitly. Obviously, if you need more room, I always encourage you to use a separate sheet of line paper. Just make sure you're properly labeling which problem you're doing so I can see which work belongs to which problem. You can never use enough paper. Always use more paper if you need to. Don't try to squeeze something on a worksheet just because you don't want to use extra paper. Hopefully this clears up a lot of confusion with these first couple problems on this worksheet, and depending on what it looks like we've got, I may allow another day to process this now that you guys know what to do. Anyway, thanks for checking this out, and I look forward to seeing you all in class. Bye.